Business Analytics students. This is lesson 5-2 on time series models. In this series of videos, we're going to work through many different time series models, so there will be more videos than normal for this lesson, since the lesson is divided into sheets according to which type of time series model we're learning about. Before we can learn about time series models, first we need to define what a time series is. So that is where we're going to start in this lesson. First, we define a time series as data taken over a period of time. The intervals that the data is collected on should be evenly spaced, which means if you're collecting information like every week, every quarter, every year, you should keep collecting data at those intervals without skipping periods of time and without changing from like quarterly to yearly, for example. It is very important you make those intervals consistent. The whole purpose of what we're learning today on time series data is to be able to make forecasts. A forecast is a special name for a prediction that's made into the future. When we talked about regression, we talked about extrapolating, which is predicting beyond the range of data. That's essentially what forecasting does too, but it's always into the future, not into the past. The reason we want to predict into the future is to be able to make business decisions and plans. If we look at a quick example, you can see in this image Amazon stock prices. These are given over a 6-month period. You can see 6 month is selected here. If I click on this link, it will open up the actual interactive chart that you can see every single day what the stock price is. So it is collected daily in this case, but I've selected the window of view to show 6 months. You could also change it to show this year so far, one total year of data from March to March, 5 years, etc. I had it on the 6-month window for only 6 months. So if you had to make a prediction for what you think the stock price is going to be tomorrow, what would you think? Do you think it's going to start going back up again? Do you think it's going to continue to go back down? That's what time series analysis is all about. And it's not as simple as it looks, because you can see if you look at the 6-month period, there is a lot of variation that sometimes we'll have the prices going up and then down and then up again and then more drastically down and up, that there isn't always a stable pattern. So in order to try to guess at what's going to happen next, like if this stock price will continue to go up or if it's going to go down in the next day or week, for example, we need to be able to talk about what patterns we see in the time series. We call these the components of a time series, and we're going to break down the components in terms of 3 pieces: trend, seasonal variation, and cyclical variation. Trend is the easiest one to see because it works just like for regression. That trend is your upward or downward movement. Here's an example of an upward or positive trend in time series data when we look at exports per year. There is some fluctuation where you see the exports go up and then back down and up and down again, but overall you can see this gradual increasing trend. This is an example of a decreasing or downward trend where we have the number of farms by year. In this case, you can see we're going down, that there are less farms over the years. Another type of component is a seasonal component, or what we call seasonal variation. These are patterns of change that must be within a year. Saying within a year is extremely important because we will look at patterns in periods longer than a year as well, but seasonal specifically has to be within a year. Usually this happens if you have yearly patterns where you have like high sales in certain months or years or weeks or even on certain days of the year. So this could be that every year your business sees the biggest sales on Boxing Day. And that could be seasonal variation since it is due to an event happening within a year. An example that we have here of seasonal variation is this chart here. You can see that if we are collecting data by quarter, like quarter one, two, three, four, quarter two is always the highest every single year. And if we look at the lowest, quarter three is always the lowest every single year. They have these exact same patterns every year. So this is what is known as seasonal variation, that you can expect to have highs in quarter two and lows in quarter three, that you have that same repeating pattern. This happens with a lot of seasonal businesses like selling swimwear. Those would peak in the summer or spring and be lower in the winter, or things like selling skis. Usually that's higher in the winter, but it would be low in the summer, for example. The reason I said for seasonal variation, it's so important to recognize that these are patterns within a year is because we also have patterns longer than a year that we call cyclical variation. This is when you have same repeating patterns, but the periods are longer than 1 year. This chart is an example of that. Notice that in this chart, if you break it up, we almost have these wave-like patterns where you have periods of prosperity where the business goes up and periods of depression. But this is over a longer period. It's not within a year. It's over about a 5-year period that you keep seeing these waves going up and down, etc. And you could break it up into about 4 or 5-year periods over about approximately a 20-year span. So because these ups and downs repeat regularly, but they're over periods longer than a year, that's what we call cyclical. We do also have a special name for time series that don't have any of these things. If your time series has no trend, no seasonal variation, and no cyclical variation, we call it stationary. If someone is stationary, usually it means they're not moving. So a stationary time series kind of means that there's no specific pattern or trend you can associate with one of these components. It almost looks random, like all the ups and downs cancel each other out randomly, that you can't say there's one definite pattern. For practice with real data, we're going to look at 4 different charts and talk about the components of the time series that are present. So first we have tablet computer sales collected by week and looking at the number of units sold. If you had to look for a clear increasing or decreasing trend here, would you say you could see a clear increase or decrease? One thing you could use to help you see that is even adding the linear trend line. If I tried to add that trend line in, it looks approximately flat. So that means no, there's not really a trend. There's no clear up or down pattern. Because that trend line's almost flat, it looks like there's not a clear trend. For seasonal variation, we would have to have like clear repeats, like every 5 weeks your sales are the lowest. But if I look at my lows and highs here, there doesn't really seem to be a clear repeating pattern by week. Like we have a low in week 2, but then we have a low again in week 10, and then we're going down again in week 17. There's not equal spacing here. So we don't have clear repeating patterns by week. For cyclical variation, this has to be in periods longer than 1 year. This is only about less than half a year of data. It's like 17 weeks worth. We have 52 weeks in a year, so yeah, we're quite a bit less than half a year. So you cannot say you have cyclical variation if you do not have data collected longer than a year. So no cyclical variation. Since I have no clear trend, no seasonal, and no cyclical, I could call this stationary. We'll come back to this one in a different color on the type of model that's appropriate in a minute. For now, we're just identifying the patterns in the time series. This one is more of a stationary time series where the up and downs just kind of cancel each other out and you get this almost flat trend. If we look at this example on coal production from 1960 to 2011, if you looked at the trend line for this one, it's clearly an increasing trend. So clear upward trend by year. For this one, the data is only collected once per year. We have data every year, so we cannot comment on seasonal variation, which are patterns within a year, because we do not have data collected monthly, weekly, or any period shorter than a year. So the data is not collected seasonally, so we cannot comment on seasonal variation. It's only collected yearly. However, this one definitely has periods longer than 1 year. It's collected over 51 years in total. That's a lot of years worth of data. So we could comment on cyclical variation, but this one, I don't see like this prosperity depression kind of pattern where you see these repeating waves. It kind of always just looks like it's increasing in general with a couple of dips, but I can't predict when the dips are going to be, like after a certain number of years. So I wouldn't say there's clear cyclical variation. Because you have trend, this is not stationary. So this is an example of time series data where we have a clear upward trend, but no clear seasonal and cyclical variation. Next, we have new car sales by month. If I put a trend line in for this one, it is going upward over time. It's not a huge increase like the coal, but there is a slight upward trend. For seasonal variation, this would have to be patterns. We do have data collected monthly, so we can comment on patterns within a year. To help us pick this out, we can try to look for when each year happens. So this would be 12 months. Here we have 20, so 1, 2, 3, 4. This would be about the second year, and this is the third year. So year 1, year 2, year 3. In these years, do we notice anything in common? I actually do notice some things in common. Like 1, 2, 3, 4, 5, 6. Like in month 6, June, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This one's a little bit different, but we do have these peaks that seem to be happening in the summer, and it always seems to be low in the winter, like in December and January. So the car sales seem to be high in the summer and low in the winter, and that does seem to be a repeating pattern for each of the years. Peaks in summer and lower in winter. For cyclical variation, do you see the same pattern over the 3 years? I would say yes, because if you draw out like a rough curve, it kind of forms this like little U or curved shape in each of the 3 years, and that is consistent each of the years. So in a period longer than a year, I have the same repeating patterns. Because you have trend and both types of seasonality, it's definitely not stationary. And finally, we have one more example of gas use over 2 years. Again, to help you with this one, we'll try to divide it into the 2 years. So if this is month 10, 11, 12, this is like the first year and this is the second year, year 1, year 2. So is there a clear increasing or decreasing trend? The trend line looks slightly decreasing, but if I looked at the ups and downs, I would say they almost cancel each other out. So I wouldn't say that there is a strong trend. For seasonal variation, this one, it's gas use to heat a house. So you can see that it's always highest in the winter months. Winter, like December, January, February. And it's low in the summer. It's actually 0 in the summer months because you would have your heat off in the summer. So this one definitely has strong seasonal variation with high use in winter and off in summers because you're not using gas to heat your house in the summers. For cyclical variation over the 2 years, do we see the same pattern? Again, this would be a yes. It has that U shape, but it's in the opposite pattern of the car sales. It's like a smiley face U, that we have the highs in the winters and lows in the summers. And this one is not stationary because we have both types of variation. So in the first one, we have roughly stationary data, then we have a clear upward trend, then we have trend seasonal and cyclical, and then we have seasonal and cyclical without a clear trend. The reason it's important to be able to identify these different factors is because that will help you to choose a time series model. There's many types of models that we can choose depending on if your data contains trend or seasonality. How we choose is we can use this chart. First, you'll have to ask yourself if you have trend or not, and then if you have seasonality or not. If you have no trend and no seasonality, you can use two different types of models, moving average or exponential smoothing. If you have no clear trend but there is seasonality, we should use multiple regression that we learned about in the previous lesson. If you have a trend but no seasonality, you can use simple regression to just make a trend line. And if you have trend and seasonality, then you have to use more complex types of models. Holt-Winters is a new type of model we're going to learn about, or you can use multiple regression as well. If I go back up to my four charts, this first one was stationary. So if we look at our options for no trend and no seasonality, that's a stationary time series. You have the option of making a moving average or an exponential smoothing model. So for tablet sales, you could use moving average or exponential smoothing. For coal production, you have a trend but no seasonality. When I have trend and no seasonality, simple regression is the appropriate model. So for coal production, I can use simple regression. For new car sales by month, I have everything, trend, seasonal, and cyclical. If you have trend and seasonality, you can use Holt-Winters or multiple regression. And finally, for the gas use, I have variation, but no clear trend. So if you have seasonality and no trend, multiple regression is the model you have to use. So you might be able to guess what we're going to do next. We have four different situations with four different appropriate types of models. For the rest of the lesson, we're going to work on fitting these different types of models so you can see how they work for these four different data sets. So please proceed to the next videos and we'll work through one model at a time for each of these four data sets. Thank you.